My topic is as software-defined network in a nutshell. I must say it's a bit different kind of view. I'm enterprise architect in government-owned company, and my mostly task is to find a way how we can bring the new technologies in data center. And the second thing what I do is put people together to use the things together and not implement stuff, you know, for themselves, and then we have like 15 SDN solutions. You will say, oh, there are only 3 on the market. There are a lot more than 3 on the market, but we will come to it as well. Okay, something about me. Why is it important? Yeah. I'm enterprise architect at DataPort. DataPort is the government-owned company which provides services for 6 German provinces. Since I'm like full certified architect, I have TOGAF certified and Archimate certified, Prince Foundation as well. I'm very proud ambassador of E2E conference, and you know, I think the best achievement I ever did is this. And if you want to socialize with me, you can give me a message on LinkedIn or Twitter. I'm also on Twitter when I'm on E2E, but sometimes it can happen that I noticed months after that somebody called me. We will speak about SDN in the nutshell, and I try to scare you now. You will see how the stuff looks in my head, kind of, in the next slide. And that's actually the structure of it. How it's, you know, I start on the empty paper, and then I put everything what I was thinking about it. That's what you see. But don't get scared. It's actually pretty simple. We will speak about why is this so important to consider SDN as a technology, what the drivers are, how your environment should look before you go to SDN, how it looks normally before that, and how it looks normally. I will explain also what SDN is not, you know, beyond marketing kind of stuff. I will also explain you what it does from abstract point of view. You know, I'm architect. I always look like from 10,000 meters. You know, I only see red, blue, and green surfaces. But still, then I will tell you what is part of me, what I did as architect to implement this technology at my company, and then we will talk about requirements which such technology would need in data center, and we will speak about architectural work as well. Now, if you have questions, please ask questions in the chat. Alex will give me questions, and then I can answer it immediately. I love this more than anything else. Yeah, I still don't get scared what's happening in my head. You know, it's like this. As I cannot change it anyway. Yeah. Okay, what is this all about? It's actually about this whole story is about management. Yeah, the management actually, you know, when it comes to network, they are driven by many stuff, and many, you know, they are driven from the customers. They're driven for management that they have above them. They are driven also to the people which are under them in hierarchy. They are driven to architects and so many stuffs, and they have to provide networking for whole company actually, and from outside and inside and all the stuff. Yeah, and yeah, the management get the questions. Okay, how we can improve our network? Why? The question is why they want to do this. And you know, I will say one of the most important factors there is a zeitgeist. You know, the zeitgeist is that we actually want to have software-defined data center, and everything should be a software-defined. Sometimes we do this also because we don't know why, but even then, you know, they ask, you know, we try to automatize everything which is important. We want to all resources to be dynamic. We want self-service, that nobody have to call anybody, so that if a service internally available, then you can call it. The applications are different now. The applications are also dynamic. They want to get resources when they need it, and they will give up resources when they need it. The developers, they don't want to call anybody. They want to code, try to code and deploy the code, and they don't want to care about on what they deploy the code. And of course, one of the drivers in last few months is the home office as well. That means you have to enable your network to be used completely outside of your environment, which was not the case in the old days. Okay, then you will say, okay, what kind of network can allow me to do that? Yeah. What you really need is actually you will need a network which you can how to say, you can talk to your network through the API. You know, everything fits together, everything got services, everything, you know, it doesn't matter which kind of network, which location, you know, it's on premise, you know, in internal cloud, public cloud, no way, make no difference, everything fits together, everything is automatized, and you know, if you want to use network as a service, it's there. You have API, you have service definition, and everybody in your company can use it. That's what you really need to achieve these requirements that you have through this new stuff. But what you probably have is this. You know, you have like a lot of people which do a lot of stuff. Yeah, you have the firewall people, you have people in different networks, you have Wi-Fi people, you have, when you're lucky, 2 kinds of networking infrastructure. When you're not lucky, like 15. Then you have administrators in every group. You have network designers in every group, and most of them don't speak with each other. They speak a lot about each other, but you know, not really. And that's actually what we have. And if you notice, there's a small gap. Yeah, you know, the picture is a black hole. But actually, what happened there is when this all requirements coming to these networking groups, they find out that they have no services and they don't have anything which works over API, or they have APIs, but they use their own internally and don't give it up, and they don't have role concepts and security concepts and everything. It's, you know, nothing is there what you really need. And that's where I come in. Actually, my role as architect is pretty simple. I try to find out where we are and where we want to go, and then make the road to it. It's something way to the target called strategy. I think that's actually my role. My role is to find strategy, how to solve such kind of problems. Okay. Let's see. Okay, and on the market, when you have such kind of problems, the people will come to you and say, hey, it's simple, use SDN, and that will work that way. And you say, okay, let's see what SDN can do for me. Yeah, that's okay. Okay, let's look into it, what SDN does. You know, we will talk a little bit the evolution, how we came to SDN as a system, why you should not use this, and why should you, why SDN is good, and what is SDN not really. And then we also smart, you know, there are big discussion on the market. It's better that these networking devices are smart, or they should not be smart. I would say dumb or smart or not so smart. And then we talk about in which scenarios kind of devices have their roles. Yeah. Okay, let's go. Any questions till now? Okay, good as well. Okay, what is doing? That's actually a job that we are speaking like 13 years. You know, we are old people. We know how Rambo 3 was great. But actually, the joke is, what is this for? And it's blue light. And the guy asked, what does it? It's not blue. And Actually, that's pretty same as a software-defined network. What we did about software-defined networking is, in the old day, we have a management, control, and data on the same device. That means all these devices were managed on device. They have a control plane. A control plane will decide how the packages go through this, and the data plane is where the data then move from A to B. And okay, when the network is getting larger and larger, we came to the point that we say, okay, it's not manageable. On every device, we put management out of it, but control and data plane stayed on networking device. Okay, what SDN actually do, he divides control from the data plane. That means control is also centralized service for everybody, and the data plane stays on device. On device is only a part which moves the data, and the agent which get how to say the rules from control how to move the data. And that's actually what SDN does. Simplified says SDN divided data from control plane. That's what this does. More is that, is not more than that. Okay, to this, you will say, okay, why I should use it? Yeah, it's actually also pretty simple. If you want that your network is API driven, that you see your SDN network as a one unit, and you want to have that programmability of the traffic, and also policy driven network, that's why you should use SDN. If you want to improve content delivery, cost, centralization, and network management, I will say it can help that these goals will be achieved, but must not be. And that's actually what a lot of people not understand about it. These are not primary goal of it. That's maybe can be if you have SDN, you can achieve these goals as well, but maybe you will not, because SDN is not more than that what is it. And actually, it's only this move from control plane and data plane. And that's you have to consider when you go in kind of SDN project. It's simply dividing from control to data plane from the technical point of view. Okay, then we will go a bit in the details. When you look how it works in the real, you will see that you have one controller which get actually topology from the networking management and telemetry as well, and has forwarding rules. And this will be how to say near real time spread over the network. And the forwarding rules are actually this what make it dynamic. That means that you can change how the packages go from A to B through the forwarding rules. For example, choose always the fastest route, choose always the nearest route, and kind of. You can also make a lot more than complicated real rules that I said today, so said now. But in the main idea is, every network has topology, and you get from your monitoring the telemetry data from all network, and you have forwarding rules. And according to three, the packages will go the way you define in forwarding rules. That's actually what happened in detail. Okay, that's how architects see what details are. Okay. When you look at the market, you have two. For everything in life, I think there are few fractions. One of them say, okay, the devices should be smart still, even if we divide control and data. And some of them say, no, they don't have to be smart at all. They only have to move data from A to B. The rules come from controller. They don't have to be smart at all. Okay. I will say, at the end of the day, it doesn't matter. As long the data and control, or I will say like this, as long as control is made centrally and spread through the network, it's like, it's kind of religious question. Do you like that your devices are smart or you don't like that your devices are smart. Okay, it's also cost is more factor about it, and I will not say that one is better than another. You can achieve that what you want to achieve with SDN means programmable network you can program with both kind of devices. That means that's not something where you should make your decision, but if you have a really high, very huge network, it can happen that your latency between the points is very, very high. That means that when the rules are spread, that that you cannot give a telemetry and everything in real time. That means that you will have a delay between something happened and where the device has to react. And in this case is better than the device is smart. That means if you are on the complicated networks where latency is a problem, maybe you should have, at least in the parts of the network where the latency is problem, the smart devices which can decide on themselves what to do. That's only thing what you have to consider by large networking and SDN. Okay. Okay, what is not? When you then look at what these all tools do, you will hear something like network management. You will see a network virtualization, or somebody will call it microsegmentation. You will see that it's actually, if you want secure network, you have to do SDN. And of course, if you want to virtualize network functionality as well, you have to use SDN. Is it true? Is it this? I will say like this: SDN is nothing of that. SDN can help to implement this as top of it, but as SDN is this not. And very important is when you do your SDN project, you have to consider that you have to realize all this stuff off top of it, even if you have it already realized. That's very important part of it for me. Okay. Where we now on the next slide. Okay. Let's go to the network management. Yeah. Okay. The controller of normal SDN system actually relates still of network management, because network management is the part of the network where the topology came from, where the initial configuration of the network came from, and where the monitoring data is coming from. I must also say management, there is not one server, as you said. Management of the network is, I will say, simplified. As my point as architect is, you have a configuration on one side, and you have a real-time data, which means monitoring and logging data, and that makes network management. That is network management. Yeah. Okay, that means when you have SDN, you still don't have network management. The centralized network management should be there even then when you put your SDN system to work. That's only a part of it. Okay, the second thing is about microsegmentation. That's one of the things I will say. Okay, they all say if I virtualize network, that means when I have this for example red point, and I make virtually that this one network and they can talk only to each other, then I make it actually more secure, because they can only talk with each other. That means they are logically separated from each other. That's more secure. Problem is that it's not so simple. And I will say it like this: where I come from, in our network, we do kind of that, yeah. But we have like between 2.5 million and 4 million lines in our control access list, and I can tell you that will not gonna happen with this system that you have of the market now. They can do between 100,000 and 200,000 control access lists, lines, and that can be a problem. That means even if you have SDN, you will not achieve that you put like a bunch of the nodes and said you can talk only with them. That will not gonna happen. You still need a smart network design, and then you can do a microsegmentation in the limit which you have for your SDN system. And that's also very important to consider when you move to this. And I will suggest do it before you start the project. Yeah, that's really important, because when you start and you think that you will achieve it, I will say you will not. And that's what is, real. The next slide. Of course, the next slide, they say if you use SDN, then it's your network automatically secure, especially because of microsegmentation. And I will say, security is not goal. Security is process, which should be defined, and also for network as well. And security should be as actually design goal, not for networks or for everything. That means you have outside a lot of threats, like phishing, like denial service attack, breach of any kind, holes in the operating system, lot of stuff. But network as a part of security system of your company is very important part, and you have to consider when even if you don't do SDN, to make your network as secure as possible by design. But security as such is few level of, it's not one layer of security. You have like 7 till 10 or 15 layers of security, and networking is one part of it. That's what my opinion about it. And most important opinion, if you have SDN in place, your network is not more than less secure than anybody else's network. But you can program your network, and that's actually achievement that you have. But it's not more secure only because it's SDN. Very important to notice. Network function virtualization actually is this, that you can realize all networking function that normally are devices or virtual devices. Now you can realize this as a function of the network. Yeah, it's true, you can do it, and that's actually where SDN is very big about it. That because you have this API, and through API you can realize almost every networking functionality with, how to say, in the backend. But one important thing about this is, in this moment when you have SDN network, you still don't have network functionalization. You have a ground for it, but it's not there. That means you still have to consider to realize all these functions. And normally is in this transition phase, you will rely on the functions you have in old fashion, and then you will move through the time. But again, when you have SDN network, you not automatically virtualize all network functionality. That's the next, is actually the next step. Okay. Normally, when I do this presentation, actually, I hope that when I explain everything and tell everything, that people will say, okay, this part is bullshit, this part is maybe okay, this part I really like, and made their own opinion. But in the past, I get few people says, okay, great, but what is conclusion? And I always say, okay, what is your conclusion? And what the people says, okay, I didn't was there really, I read the messages on my Twitter and everything, I hear you a bit, was nice, but yes, that's mean the instant conclusion is what you achieve through software-defined network is you have IPI, you have network as one, you have whole network, which is SDN network as one unit. You can make traffic programmable, and you can have a policy-driven network. And that's, if you want to achieve this, SDN is actually what you will achieve with SDN. Network management, network security, microsegmentation, and network function virtualization is something which you can achieve when you have kind of network. You can achieve it without SDN as well. Yeah, you can have perfectly secure network without SDN. If you have insecure network, SDN will not make it more secure. And same as if you have a screw up network management, then you put SDN in place, you will have, yeah, I screw up network management with SDN. That's what I want to say. That solves none of problems you have on the front end of your network. That means on this project, these problems you have to solve these problems as well. But what SDN will give you is network which you can program on it, and that's actually very much. I will say that's really very much, but it's still not solution for all networking problem that you have. And I will say when you have networking problem, you should solve them before you go to SDN. Yeah. Okay. Now we come to this what to buy. I'm architect, and that's actually a simple solution. Look what you have, how your networking, how your servers are, what your skills are, and then you can decide what you can buy on the market. If you use container, then you have to use something which works very good with container as well. I will say more as for architecture point of view, there are no more to set. I can tell you they are okay. You know this old 3 big player. You can use a solution from them. There are few very big open source projects which have a very broad support from industry. VONOS, Open Daylight, and Open Control. And you have also 2 projects where you have a huge community, which is actually free, academic, but not supported by companies. And that's Open vSwitch and Open. But from architecture point of view, I don't really care. What I care is how you will implement this, and that's where we go in the next step. Okay. The next step is normally what we do is when we finish with everything and then watch inside it and look technology, do the test, try things, do a few workshop, we will sit, or I will sit and say, okay, what are my requirements on this technology? And I will go fast through it, or fast as I can, but you know, the idea is, okay, when we want to do SDN, we want to do this in automatic way. We don't want people do anything inside it with the hand of configuration file. We want only API. You will use it through API and nothing else. Network management will be on top of it, but the SDN network will use only through API. That's the first thing what we want to do. We want also possibility that we can do the data flow optimization on application base. That means that we can prioritize application and set for every application how the data flow will be. We want, of course, that it's fault tolerant, which has not so much with SDN. It's not really SDN topic, but it's part of it. But you know, topology must be as such that we have fault tolerant network beneath it. Also, it's important that you will not move all network to SDN in one day. I will say if you do it in 3 years, that in scale where we are, it's great. If you do it in 3 years, I will say great. I will also say more, maybe you will still have after 3 years part of the network they are not moved, but really important is that you can use it as, you know, like you start with one part of the network and make it bigger through time. That's actually the most important thing. You should support, the solution should support microsegmentation, but in smart way. That means between the boundaries of the system we use. It must be a possibility that we can detect anomalies in data flow. We want that also the secure connection between a network endpoint is possible through this SDN solution. It's also that all SDN controllers and all network components must be connected through mutual trust. Means that all controllers can get only the components which are allowed, and other way around. That means the component can be only from the controller which is allowed. That's really big. And okay, I didn't tell that, but normally authentication is on northbound interface. That means where you came to this, where the API is, that no connection without authentication. That's actually the requirements which we find out work for us. We also, because we have complicated network, we find out that also we have few requirements which are obligatory, but only when possible. And that means secure communication between SDN controls and the agent. That's what we really want to have, if it's possible, technically. We want that all network components communicate in out-of-band network, which is not very always possible in WANs. And we, of course, we want to use this for all possible network types. But sometimes they will come to two different solutions. And on this case, when we have two different solutions, it's more important in first step, both solutions have these requirements. And when the requirements are achieved, then we can go and look if we can merge them together. That's the main idea of it. Okay, that's let's go to the next slide. Okay, and when we have requirements, then we speak with stakeholders, and stakeholders are not only management which you get contract from, that's also the network designers from all these networking parts and all administrators that you have. And what you give to him is the target architecture. You give him how you think that should look from your perspective, you know, green fields and black fields and red fields and stuff from architecture point of view. And then you do and try to make together solution architect out of target architect. And then you make strategy with them how you will achieve this goal. And that's the moment where the most part of the architectural work is finished, and then you will only be in this project to watch over that what will be achieved, that's what you think they should achieve at the end. And yeah, that will be the end of this presentation. And I saw yesterday a very nice quote, and I thought, oh, I want to have smart quotes as well. And the quote is, remember, without data, you're just another random spaceship captain. And yeah, that will be everything for now.